Hello everyone, my name is Brandon Lira from the DLSU Biological Control Research Unit, and I'm going to present about recycling disposable cups into pipette tips. So the COVID-19 pandemic happened and we're still in the middle of it, right? Aside from eating out, which we usually do, we instead to opt to order food for delivery to enjoy them in the comfort of our own homes. Over the months or years that passed by, did you notice that the restaurants or stores have shifted from using disposable plastic containers to a somewhat paper-based or biodegradable packaging? From this single-use plastic packaging to this paper-based packaging. So yeah, because single-use plastic is bad, right? There's so much attention given to plastic waste. Now, to recycle plastic or repurpose them, there are steps that can be ranked into four categories. The first and the best way to recycle plastic is by depolymerization to obtain the constituent monomers to produce new plastic products. The second is by conversion into lower grade plastic products. So, examples of low grade plastic products are those that are used as plastic bags, sachets, or candy wrappers. The third is by incineration. So if the first three options are not feasible, the fourth and the last resort is by disposing them into landfills. So what are the alternatives to these plastics? You might say paper, but not all paper packaging are created equal. So and not also knowing that these biodegradable alternatives also do harm. Instead of using these kinds of microwavable containers, which are commonly made of polypropylene, we opt to use this one. On a side note, you can check the bottom of your containers. Polypropylene plastics have this triangle symbol with the number 5 in it. So the number 5 is just the recycling code for this kind of plastic, which is polypropylene. When you buy ice drinks, say from Starbucks, some branches already shifted from these kinds of plastic cups made from polyethylene to a paper cup. Notice that the insides of these paper packaging materials doesn't get soggy immediately and are kind of covered with a thin plastic film. This plastic film helps protect the paper or the cardboard from getting wet and soggy immediately. Not all of the paper packaging are lined with plastic, but majority of them already have, especially when its purpose is to hold liquids or sauces. These kinds of material are called as paper plastic laminates or PPL. These materials are among the single-use plastics that are challenging to recycle due to the thin plastic film coating the cardboard or the cellulose material that needs to be separated. Here is the image that shows a degraded paper coffee cup from with its plastic lining still intact at least over a year in the compost. Since it is made from paper, okay, it is perceived as environmentally friendly and recyclable, and that it may be included along with the biodegradable wastes, but majority of them actually not. Aside from their accumulation in the environment, the global warming potential of these disposable cups made from PPL is another important environmental issue. We can reuse plastic containers, right? But not so much for these paper plastic laminates because they become soggy when wet and their long-term structural integrity is not stronger than plastic, especially when they become crumpled. What if there is a way that when we can reuse these PPL by creating something more useful, especially in the academic setting? Aside from our everyday lives, plastic waste in the laboratory are also problematic. For those of you who have taken face-to-face biology lab or biochemistry lab classes and are familiar with using pipettes, we use these plastic pipette tips that are single-use. These tips are used to deliver a specific amount of volume from one place to another. We dispose every single one of these pipette tips once we are done using it. And the plastic is commonly made from polypropylene. In an effort to promote plastic recycling, especially for this type of waste, we present a method of creating laboratory pipette tips out of used PPLs. We have created them in a way that will maintain their structural integrity even when wet. Besides, especially in teaching laboratories where it's kind of okay to not be 100% super accurate in delivering volumes. And this proof of concept not only presents an innovative method of recycling disposable cups or containers made from PPLs, but also promotes sustainability in research and teaching laboratories, which also contribute some substantial plastic-based products. So to make these PPL pipette tips, the main materials that are needed are a clean, and in our specific example, we used a plastic lined coffee cup, which actually from Starbucks, and a quick dry adhesive or an adhesive tape. The used PPL cups were first cleansed and disinfected with a hypochlorite solution and left to dry at room temperature overnight. So here is a template for the PPL pipette tips. Okay, and the steps of rolling the cut sheet into the PPL pipette tips are illustrated here. So for the first step, the upper right edge of the template must be rolled inwards to the left and upwards, and the bottom apex must be rolled inwards to the right and then upwards. So these two steps must be done simultaneously to achieve the cone shape, the form in the second step. Okay, so from this second step, the letter B, the edges of these are lined with an adhesive and further twisted to achieve a cone shape. And this paper tip will be used as a substitute for the common plastic pipette tips. In our specific example, we designed the paper tip to hold a volume of 1 ml. Now, to verify if these PPL pipette tips can deliver volumes comparable to a standard 1 ml capacity polypropylene blue pipette tip, three PPL pipette tips were prepared and were compared against three randomly selected polypropylene pipette tips. So for this purpose, a single BioPet brand pipette was used throughout the experiment and was said to deliver a volume of 1 ml. Each pipette tip was used to obtain 1 ml distilled water, and the contents of the tip were dispensed in a tiered beaker on a laboratory balance, and its weight in grams was recorded. So this was done for 10 replicates for each tip, all in all having a total of 30 trials. Since the density of the distilled water at standard temperature and pressure is 1 gram per ml, the mass of the dispensed liquid should also be close to 1 gram. So as this first table shows, the PPL pipette tips have a statistically similar performance to the standard polypropylene pipette tips based on ANOVA. Moreover, looking at the second table, the three PPL pipette tips demonstrate reliable structural integrity since their performance remained consistent despite being used for 10 times each. Okay. To conclude, the performance of the PPL pipette tips is statistically comparable to the standard polypropylene pipette tips. This makes the PPL pipette tips as a viable alternative that would help lessen the pollution from single-use items. The created PPL pipette tips have promising potential to be used in lower-level science experiments that do not require research-grade laboratory consumables. So, as an example, these PPL tips are ideal in the introductory skill-building activity on how to properly use a pipette wherein like food-colored water is used as a specimen, for example. The presented proof of concept that recycles paper cups into useful and accurate pipette tips is a promising addition to existing technologies that likewise aim to manage seemingly dead-end plastic product. So actually, last 2020, we have actually filed this patent grant application to IPO field. And with that, we acknowledge the DLSU Intellectual Property Office and the DLSU Innovation and Technology Office through the help of Mr. Peter Tenido, Attorney Christopher Cruz, and their whole team for a big help in assisting us to file these patent documents. So thank you very much for listening.